Hey, what's going on, guys? This is ASVAB. Today we're going to be covering ratios and proportions, right? I'm going to be going over ratio and proportions when I'm showing whether it's proportional or whether it's not proportional. We have two examples. So as you can see in question one, this is typically how it'll look. It'll either say 50 to 30 and 1 to 2, or it'll look like this: 50, 30, and 1 to 2, right? Now what that's going to look like in fraction form, I guess you could say, is 15 over 30 equals 1 to 2. Now the thing that you need to remember when it comes to this stuff is it must all be proportional, it must all land towards 1 when it comes to the simple ratios, right? Another thing that's extremely important when it comes to ratios is you're supposed to keep the categories in the same area, right? So let's give an example. We're going to say that this is sugar. We're going to say the bottom half is cookies. That means the numerator up here, this should also be sugars, and this should also be cookies, right? So the bottom half is all going to be cookies, the top half is going to be sugar. If you break up this and you put them in different orders, you're just going to end up making it wrong, right? Now that we've got it formulated correctly, we're going to go ahead and reduce these because we can, right? Now the difference between reducing and multiplication versus ratio, when it comes to multiplication, think of it as a bow tie, right? You can do diagonally and you can do vertically, right? But when it comes to ratios, you can only do horizontally and vertically. You can't do diagonally, right? So think of multiplication reduction as a bow tie. Think of the ratio reduction as a square, right? So with that being the case, let's go ahead and reduce. So 15 can go into 15 once, 15 can go into 30 twice. Right? Now that that's done, we're going to go ahead and we're going to be able to cross multiply, right? That's another difference between multiplication in fractions and multiplication when it comes to ratios, right? Now, you see how this shows as an equal sign? With that being the case, we're going to go to essentially what it was for division. Keep, change, and flip, right? So with that being the case, it's going to look like 1 over 2. We're going to keep that. Change, it's going to go to multiplication, 2 over 1, right? Now that that's done, what it's going to be is 1 times 2, that's going to equal 2, and 2 times 1 is going to equal 2. That will just end up equaling 1. We know that this is proportional because it ends up equaling exactly the same thing, right? Now let's go over this one. This one's going to be 4 over 7 equals 6 over 9, right? Now going through reduction, like I said, we can either do vertical or horizontal, right? So these can't be simplified, right? But these can. This can become 2. This can become 3. Keep, change, flip. That's going to be 2 over 7 multiplied by 9 over 3, right? 2 times 9, that equals 18. 9 times 3, that equals 27, right? With that being the case, 18 over 27, it can get simplified further, right? That'll end up equaling 2 over 3, right? However, because it does not equal one number, how this one did, this is actually considered non-proportional. So it's incorrect, right? And that's how you go about this. This is the point of ratios versus proportions. And the reason why this is important is because in fractions, you're getting the part over the whole to get whatever the totality is. Whereas the difference in ratios is that not all parts are going to be equal. And that's what the ratio is for. To give a couple examples, 3 to 5, 5 to 2, 3 to 7. That is the difference when it comes to ratios and proportions versus multiplication when it comes to fractions.